I'll be your presenter as well, and this week we'll be discussing coding a simple image recognition ANN. We'll look at the background on neural networks, how to code this neural network, and applications of image recognition and ANNs. The neural network, as a recap, is really made up to look like the actual neural network that makes the brain. So if we look carefully at the neuron, you will notice that the neuron resembles the quote-unquote neuron in the neural network. It has many inputs and one or more outputs. Okay, so the inputs may be in form of dendrites, and the synapses are fired only if that input meets the required weight for that value to be input into that neuron. And this is the same approach for the artificial neurons in the ANNs. So if we take a look at the neural network, we can have one or more layers to do the processing, the actual processing in the network. So moving on to image recognition neural network, you notice that this is the overall diagram of how it's done. We have an input image, split up into overlapping images, feed all these in separate small neural networks. We downsample it and then pass it over to a fully connected neural network and make a decision on whether it's a match or not a match, depending on what we are looking for. Okay, so this image is not passed as we see it, but to a computer we pass it as values, okay, numbers, and in AI these are normally referred to as tensors. So to code an image recognition neural network, before, the approach was images, the training images were put smack in the center, okay, and if they were slightly moved, the images could not be identified, which was not working, really wasn't working. And the next approach was a brute force approach of moving a window around the image and trying to center the image in that window to determine whether there is the desired image or not. Still very inefficient, because that whenever that window moved, it required a lot of reprocessing. The next approach, brute force approach again, was taking the training image and generating many versions of it by a script to train the network, which again is very inefficient, especially for high resolution images, and when we're dealing with images that are so many and that require constant refreshment. So the solution was to introduce convolution. Convolution is what we saw earlier, this approach here, where we have an image broken down, fed into separate small neural networks. The results are downsampled. Okay, one way to downsample is max pooling. Another way could be averaging, Another way could be the highest frequency, and so on and so forth. So this is one approach to actually reduce the values, and it can be done. Convolution and max pooling steps can be done so many times to get to a value, a tensor result that can be passed to the fully connected neural network. One approach here is we have so many steps, okay, where we do convolution, max pooling, convolution, max pooling, convolution, max pooling, and then we get the result. This is just one approach. Again, it's not the only approach. There may be many other versions for achieving the same thing. Here we see the applications of ANN in image recognition. One of them is during navigation, automated navigation, license plate recognition, and facial detection, which most of us use in our phones, as well as in security applications. For example, for fingerprint recognition, facial recognition, searching through an image database to pick up a face, and so on and so forth. This concludes the video version. I encourage you to join the Google group to get the code that we used in the meetup, and also try it out on your own. Next week we shall be looking at how a smartphone actually works. I encourage you to come and join us. Thank you.